Hey, what's up guys? Mr. Flores here, and this is the second video on scatter plots, okay? And like I said, this video on scatter plots is going to just focus on a line of best fit, okay? So, if you remember from the last video, line of best fit is basically this line that we use to estimate data in our graph, okay? So, the line of best fit, again, we use it to estimate data, okay? So, for instance, say we didn't have, or if you look here, we don't have any student, or we didn't have anybody in our survey that was the age of 13, okay? But using our line of best fit, we can estimate, okay, that a student, or anybody who is age 13, is going to have a size 9.5 shoe, okay? Lines of best fit are used a lot in the outside world, okay? For instance, in college, one of the projects I did over the course of a whole semester was there was a guy from Europe, and he designed this new type of house that was very, very energy efficient, okay? And he wanted to see if it would work in the United States. So we basically split up into two teams and did a whole bunch of math calculations, and we made a lot of lines of best fit, some linear, some not, okay? And basically, we used the data from his European houses and used lines of best fit to calculate and estimate how much money it will cost in the United States, okay? So lines of best fit are used to estimate data, okay? Again, like I said before, scatter plots are something you can get very in-depth with. Likewise, a line of best fit is something you can get very in-depth with. We're just going to be touching the surface in this video for our sake, okay? But the one thing we can look at and realize for a line of best fit, it's just a straight line, okay? It's linear. If you have a positive correlation, it's an increasing line. If you have a negative correlation, it's a decreasing line, okay? So if we know that really when we have lines, okay, we like to put our lines in y equals mx plus b, okay, where m is our slope and b is our y-intercept, okay, because this is slope-intercept form, so slope-intercept form, okay, and once you get your line of best fit, you can use it to estimate data, okay, and lines of best fit, if you have a fancy graphing calculator, or we use Desmos, you can get a very, very exact calculation, okay, but for this video, we're just going to be calculating the line of best fit by hand, okay, we're going to use the good old-fashioned pen and paper or computer, touchpad, and smartboard version, because I'm not using pen and paper right now. But, so you know, this is the most basic way of doing it. You can calculate it by hand the advanced way, the same way a calculator does, but the math gets very tedious, so we're just going to do it a very, very simple way, okay? And basically, all we're doing here is we're finding the equation of a line that goes through 2 points, because if we think about it, we just have a bunch of x and y coordinates, okay? So what we're going to do is we're going to take 2 coordinates, find the equation of a line. That's going to be our line of best fit. So the first coordinate I want to use is 2, 82, and let's use 5, 96. Okay, so our 2 coordinates are 2, 82, 5, 96. All right, the hours studied is our x variable, the grade is our y variable. That's because the more hours you study, you should get a higher grade. So your grade depends on the hours studied, and whichever variable is the one that is independent, okay, since the hours studied doesn't rely on anything, that's your x variable. Okay, so when we find the equation of a line, and again, there's a whole video on this, so I'm going to go through it kind of quickly. The first thing we always need to find is our slope, or our m. Okay, if you remember, the equation of slope given 2 points is y2 minus y1 over x2 minus x1, or more simply put, the change in y over the change in x. All right, so what we're going to do is we're going to calculate that. So I have 96 minus 82 over 5 minus 2, okay, which simplifies to give us 96 minus 82 is 14, okay, 5 minus 2 is 3. So we know that the slope of our line is 14 over 3, okay. So what I like to do is whenever you find something, write your equation with what we know so we can still see what we have to find. All right, so our equation is going to be 9 equals 14 thirds x plus b. All right, in order to get the equation of a line in slope-intercept form, we need a slope and a y-intercept. Well, we found the slope, we still have to find our b. So what we know that we can do, since we have a y and x that we want to fill in here, we have two coordinates, 282 or 596 we can substitute in. I'm going to substitute in the 82 and the 2, so it's 82 equals 14 thirds times 2 plus b. All right, 14 thirds, when I put my calculator, times 2 comes out to 28 thirds. So we have 82 equals 28 thirds plus b. Okay, if we want to get that b all by itself, we're just going to subtract 28 thirds from both sides. All right, so we're going to get that b is equal to 82 minus 28 thirds. It comes out to 218 over 3, or roughly 72.67. Okay, so using our slope and y-intercept, we know that our line of best fit is y equals 14 over 3x plus 72.67. Okay, this is our line of best fit. We can use this line to estimate data for this certain scenario. Okay, and one of the things you should notice about this line is that we know that the hours studied, the more you study, the higher your grade is. Therefore, we know that it's going to have a positive correlation. Well, we also know it's a positive correlation because the slope of our line of best fit is positive. Therefore, if we were to graph it, the line would be increasing, okay, since it has a positive slope. Therefore, to have a positive correlation. Right? So what we're going to do is we're going to use this line of best fit to help us estimate some data. Okay, so we have y equals 14 over 3x plus 72.67. Okay, so let's say we're posed with a question. If a student studies for 4.5 hours, what grade should they anticipate to receive on their test? Well, if we go back to the data collected, no student studied for 4.5 hours. Okay, but we did have a student that studied for 4 hours and got a 90, 5 hours got a 96, so we're going to say it's somewhere between there. But with our line of best fit, we can calculate what they should get. Okay, and again, I keep saying what they should get, or anticipate to get. Okay, because the line of best fit, all it does is gives us an educated guess. It's not definite because nothing's perfect in the world. Okay, so what we want to do is if you think about it, we want to see how many, or if a student studies for 4.5 hours, what grade should they get? If you go back to our table, we know that hours studied is our x variable. So all I'm going to do is substitute 4.5 in for x. So it's 14 over 3 times 4.5 plus 72.67. Okay, I'm just going to plug that all into my calculator. So 14 over 3 times 4.5 plus 72.67, giving us a grand total of that y equals 93.67, or roughly a 94% on the test. Okay, so if a student studies for 4.5 hours, they should get about a 94% on the test. Okay, and if we look back, it says that we should get a 94. Well, that's between 90 and 96. Okay, so that's good sense. It's a good approximate value. Okay, so that's something we can do with our line of best fit. Something else we can do is we can say if a student wants to get a 92 on the exam, approximately how many hours should they study? Well, again, we're going to use our line of best fit equation, but this time we have to think, where are we going to substitute the 92? Well, the 92 is the grade they get on the exam. If we go back to our table, the grade is your y value. So we're just going to substitute 92 in for our y value and solve for x. Okay, so you have 92 equals 14 thirds x plus 72.67. Right, we can subtract 72.67 from both sides. Okay, so we're going to get 92 minus 72.67 gives us 19.33 equals 14 thirds x. Okay, if we want to get x alone, we can divide both sides by 14 thirds. and we're going to get that x equals 4.14 hours. Okay, so if a student wants to get a 92 on their exam, they should approximately study for 4.14 hours. Okay, and in a nutshell, that's a line of best fit. A line of best fit is an equation of the line that we use to approximate our data. Okay, and again, if you don't have fancy graphing or technological software, you can just use the good old method of finding the equation of a line that goes through 2 points. Okay, to find your line of best fit. Again, like I said, line of best fit is one of those things that can get very, very in depth, or it can be very, very brief. Okay, this is kind of a brief introduction to it. If you have questions, let me know. Again, basically this video is nothing new. Okay, it's just taking concepts of evaluating equations, solving equations, finding the equation that goes through 2 lines. A lot of the stuff we've been doing, it just takes it all, combines it together, and makes it applicable. Okay, it makes it useful for real life. All right, and lines of best fit come up all the time. So if you have questions about it, let me know. If you're still a little tricky on scatter plots or any of this stuff, come see me, send me an email, rewatch the videos. Have a good one.